Hello students. Today I'll be just showing you some of the breeding techniques, especially the chemical mutagen breeding techniques that can be used in mulberry. I have few slides to share with you, and I would just show you some of the important features of this breeding technique that's being used in mulberry. Um, I made a couple of slides for this, and let me just go through the slides and open those slides to uh, present before you. Well, this chemical mutation breeding, this is one of the presentation which is being made for international conference and which has already been presented. But now I'd like to just go fast. Okay, I'd not take much time. I would just go to the highlights of this particular, mutation breeding techniques. Okay. Uh, Now, before that, these are all the slides which speaks about sericulture, and I would not like to just go into those details. Look at this. This is one of the cocoon markets present in Karnataka, which is the largest cocoon market in Asia. This is some of the techniques you see which are used to produce silk. Um, and these are some of the byproducts of the silk. And these are the 4 types of silks that you can just see. And look at this. This is our Tassar silkworm yarn, silkworm cocoon and yarn and skeins, and these are eri silkworm. These are eri silkworms, the non-mulberry silkworm, which produces this kind of yarn. And look at these pictures, and this is the yarn. And now I just go into this. For all this production of silk, especially in sericulture, mulberry becomes the central dogma. Why? Because that is the you know forage that is being used to rear silkworm, and the silkworm produces silk out of this, and there is a direct impact of what you call on the cocoon harvest and economy, and the mulberry protein that is being converted into silk protein. Nearly about 70% of the mulberry protein is biosynthesized into silk protein by the silkworm. Now, okay, these are all I would come to this main aspect, that's methods of breeding. You have conventional method and modern method. And the conventional method, you have the selection. Look at this selection here. You have a natural selection and artificial selection. And artificial selection, you have mass selection, pure line selection, clonal selection, and then you have again what we call pure selections. Now, when you come to these hybridizations, now you have these 1, 2, 3, 4, no, 4 types of this hybridization techniques. And then these are the modern methods of breeding. One is the mutation breeding technique, and you have polyploidy breeding technique, and then you have biotechnological approaches, where under that mutation breeding, you have a physical mutation breeding and chemical mutation breeding. And polyploidy, you have different types of ploidies, and then we make use of these ploidies for improvisation of crop. And the latest and modern methodologies in breeding is biotechnological approaches. We use genetic engineering tools, tissue culture and micropropagations, and so forth. And I would just straight away now go into this, mutation breeding tools and its applications. Now, the tools are these mutagens, the plant material, the experimental tools, statistical methods, and multi-locational field trials. Now, we have this mutagens, becomes, which we apply to bring in mutations. So this is the applications, like the selection of mutagen, the determination of dose, and the duration of the treatment. And then you have a plant material, which is again an important tool, and how you use this, and it becomes, as an application. Now, there is selection of stock, germ blossom bank establishment, nursery establishment, and then selection of plant material and treatment, and so forth. And then you have another is experimental tools. We have, these are the tools that we use is screening and evaluation, and parameters that is being used for field studies, various qualitative and quantitative, and investigations of biological assay, protein profile, and then molecular characterization and photographic documentation. And ultimately, all these results need to be analyzed statistically in order to establish its significance, and then prove that they are the promising and elite varieties. If it need to be essentially introduced as a new variety, and given to the farmers for a large scale production. Now this is what we use, the statistical tools, and various tools can be used, and then finally we come to the conclusion. And once when that is being proved by the statistical analysis, data analysis, then we put them to the field, the multi-locational field trials, and we just produce them as produce and release them as an what you call improved varieties. Now, how do you carry out this? And this is the final schematic presentation which I'm going to show you. Now, in this particular breeding methodology, I made a schematic representation that how you can go ahead. Now, starting from the beginning, the first is that you'll have to make a selection of our parent material. Now, in which particular race or in which particular species varieties you need to produce and evolve and high yielding variety based on some of its characters, very strong and potential and promising characters as an elite one. So from those things we try to choose, and you see those are available in national breeding research stations like your CSRGC. So this is Central Sericulture Research Germplasm Station, which is stationed in Hosur, Tamil Nadu. We need to just procure the material from them through a proper procedure and protocol, and then that procured material has to be established in the germplasm bank in your station, in your research station. That is called as establishment germplasm bank. And look at this next stage is selection of genotypes for mutation induction. Now you need to select the genotypes from your germplasm bank. You would have chosen varieties, plenty of varieties, and out of them, how many varieties you need to just choose for your experimentation, it has to be determined. And that is what is the selection of genotypes for induction of mutation, because they are using this mutation breeding as a tool to bringing in evolved varieties, high yielding varieties. Now from that, you're going to first raise the cuttings in nursery and then go for a treatment. So the next stage is treating those cuttings on sprouting. Now the treatment has to be done. Now here you've chosen as a chemical mutagen as a tool to bring in mutation. Therefore, this is a chemical mutagenic studies. So you treat with different concentrations. Then the concentrations need to be determined, and it has to be decided based on the material, what kind of material you are going to treat, the age of the material, and the part of the plant body which you are going to use for the treatment. Now that is what main thing which plays a vital role here, that how you need to decide the dose. And this is called as dosimetry. This all depends on trial and error method, and then you'll have to decide the concentrations. Now we choose these concentrations and treat them, and then once when it is treated and put back them into nursery, maintain them in standard nursery conditions in the first few months, that is say around 3 to 6 months. So in 3 to 6 months it raises themselves into clones, and these clones now you harden them and then transplant them to the field. So this is called the first generation mutants, and these first generation mutants, you put them, they are called as M1 V1. That means the V1 are the first generation variants obtained from the mutation 1. Now then subsequently, after maintaining in the field for say around a year or so, you screen them for evaluation. There's a selection process. There's a selection process. You need to follow the standard selection process, and then you screen them. Out of that, the best one are chosen, and again from them you are going to make the cuttings. Then you propagate them for the subsequent generations, which becomes M2 V2, and this is the second variant. Now you always try to just compare with this M1 V2 and for the consistency of characters. Now, whichever shows the best consistency and retaining the characters, so those are the elite, what you call clones, we call them. And these elite clones are once again chosen from that population. And again, you got to just propagate them for the subsequent generation. That we call it as M1 V3 generation. So that from the mutation 1, this is the variant 3, and this particular variant 3 becomes what you call the third generation variants. And at every level, when you screen for the characters, the consistent characters. The population which shows the demonstrate the consistent characters every time, and those consistent character demonstrating clones are selected, and the rest of them are rejected. Now that means to say these clones have fixed their characters in exhibiting the best what we call traits in terms of the qualitative and quantitative characters. So the quantitative becomes the yield. That means the amount of the biomass that produces per hectare per annum. And the qualitative characters are various biochemical properties, phytochemical properties, or the phytochemical constants of the leaves. And these has to be, analyzed, and these things are done at the laboratory level. And once when they show the best characters, that's what at every level you see you're going to do. One is the quantitative character analysis, another is qualitative analysis, right from the stage M1V1, M2V2, M1V1, M1V2, and then again M1V3. Now that means to say in every stage you're going to screen them, and finally the best performing clones are chosen, and they become the evolved variety. And once these results are obtained and statistically analyzed and based on its significance value, and these are declared as a best performance and high yielding variety. And these high yielding varieties are taken up for a large mass scale production, putting them into multi-locational field trials. Now we put in different locations with the different agroclimatic conditions in a state or in a country, and then we try to see its performance. So then once when it is performing well, we choose them and release it as a new variety to the farmers. So this is the overall, I've just put everything in a small, in a nutshell, and the details would be dealt in my subsequent class or in my subsequent videos. Please go through these things, and there are various links through which you can understand about the breeding, which I would also try to give these things, these details in my email. Okay, thank you.